or club activities or astronomy in general?
I got a few pictures of my new telescope I'd like to share.
Oh, go for it.
Well, it's rebuilding my old telescope. Yeah,
if anyone's seen
share my screen, I'm getting a message: host disabled, participant screen sharing. Can you let me share my screen and then I can?
Geoff, you're muted.
Yeah, sorry. I'll make you a co-host. Just have to find you in the list.
Yeah, if anyone's ever seen Keith at Moon over Monona Terrace with his really cool homemade telescope, it's really neat.
I'm still getting a message and can't share my screen.
Oh,
now you can.
Try it now, Keith.
Okay, here we go. Let me do.
We're used to locking things down pretty tight for public events.
Yep, understand.
There we go. We can see it, Keith.
yeah. See, I'm back there just eyeing it with envy.
Yeah.
Keith, that's got a little bit of a William Herschel feel to it.
Oh, yeah. And the octagon. Well, this is the old one. There were a couple of improvements I wanted to make to this. One, it was kind of heavy. And the other thing is it's a little bit too long to fit into the new car that I just got. So this is what I came up with. This is my woodworking project for over the winter.
Neat.
It's in two different sections. I decided on a box within a box kind of arrangement. So it's a telescoping telescope. The smaller box slides down into the bigger box.
Is that the same mirror inside of there as your old one?
Yeah, it's the same mirrors. I just wanted to redo the tube in the stand. Here's a close-up. See the viewfinder and the focuser on top. And in the corners, I have some places to store my zoom eyepiece, and also a Barlow lens down here.
Oh, neat.
On the opposite side, I got the laser collimator. There's a little pocket for storing filters and stuff. And then, well, the viewfinder comes off and it stores inside here. The focuser is on a hinge and it just hinges down. This cover that I have over the secondary mirror, I use as a little pouch to store the lens caps off of the viewfinder and on the eyepiece. And it's got a little piece of Velcro, and I just Velcro it to the inside of the stand here. And then it folds up like this. I carry it like this.
Nice. That's really impressive.
Yeah, that's really neat. You're going to have to patent that.
Great concept.
And then I have an artist friend who painted some things on the altitude bearings. This is the galaxy M109, which is near the bowl of the Big Dipper. Then on the other side, I have a planetary nebula in Cygnus called the Blinking Nebula. Blinking planetary. And yeah, I'm pretty happy with how it turned out.
Very cool.
I smell a story for Sky and Telescope in there.
Yeah.
Telescope
Well done.
Well, this top part of it is made out of marker board too, so it's nice and waterproof. And you got a little Sharpie marker Velcroed into the inside here too, so I can write on top of it if I wanted to.
It was after 7:30, so Keith, why don't you go ahead and surrender, and let's get back to Geoff. I'll introduce Geoff in a minute. Just for everybody's information, tonight our guest speaker is Geoff Holt, the planetarium director. Most of you have met Geoff before, probably several times. Geoff has with him tonight, virtually speaking, of course, several students from Memorial High School who've been engaged in a research effort with him and with some other people throughout the country for the last year or more, Geoff? Yeah, you're muted, Geoff.
2019.
Okay, so for quite a while. And they're going to present their research tonight, as well as share a little bit about their trip to Hawaii back in January. Just got that trip in under the gun, didn't you, Geoff? So I'm going to turn it over to Geoff. The way we're going to handle questions tonight is I would like everybody, if you have a question during the presentations, to type your question into the chat window. I'll be keeping an eye on the chat window as we proceed. Since the presentation is going to involve several people, Geoff is going to hand it off to his students. Rather than having questions interrupt Geoff and the students, we're just going to save those questions until the end. When Geoff and the kids are done presenting, then I'll go back to that list of questions in the chat window and I'll recognize you one at a time and have you unmute yourself and ask the question. And looking over the chat window, I think most people have got their names in there. I do see a couple of oddballs. So iPad 3, if you have a question, I will be recognizing you as iPad 3 because that's all I can see. Jurgen, you're in there with some initials that nobody else might know, but I know. So if you do have a question, put it in the chat window and we'll get to it after Geoff and the kids are done. So without further ado, Geoff Holt from the Madison Planetarium and his group of Memorial students.
And just so you know, I'm not in the planetarium. It's just a virtual background. The school really is closed. All right. I was just thinking if I wanted to say anything before we start, but I can't think of anything right now. So I'm just going to go ahead and share my keynote. What I would recommend is that you now switch to speaker view so that whoever is speaking will show up over on the right. Let's go to the first slide though. So then as we switch speakers, you'll be able to see, for those of us that do have cameras working, we'll be able to see who's speaking. So like John was saying, I got accepted into the 2019 series of this program called NITARP. It's actually an annual program. And so we have another staff member, Ben Sensen, who is leading actually some of these same students and others in the 2020 class. The program is called NITARP, and it stands for NASA IPAC Teacher Archive Research Program. Its goal is to give teachers experience doing actual astronomy research, and we have the option of getting our students involved as well. And I have to say that I am very pleased that I did, in fact, get students involved, because that's been the best part of it. And this is the adult, or at least professional adult members of our team. So we've got teachers and then our astronomer on the right side. We happen to span all 4 time zones. So part of the challenge was logistics and just being able to have our meetings together, but it actually worked out really well. And then these are the students from Memorial High School. That's James Madison Memorial High School, who stepped up to the invitation to participate. And I'd like to have each of them introduce themselves. But before I do that, in fact, I'm going to stop sharing my screen so that you'll be able to see at least a couple of the members' faces a little bigger. But Kyle, who's on the meeting, does not have a camera that he can activate right now effectively with his bandwidth. And same is true for Isaac. So roll call, Kyle and Isaac, when they're talking, make a mental picture of their faces right now, because this is the best you'll get. All right, so I'm going to bump out, stop sharing my screen, and we'll have each of them introduce themselves now.
Yeah, hi, my name is Isaac. Like Mr. Holt said, my bandwidth is being very mean today, so I don't have a camera up. But I'm a sophomore at Memorial, and some of you might have recognized my picture or somehow recognized my face or my voice. I don't know how you do that, but I actually presented about NITARP at MAS a little bit ago in hopes of fundraising for our actual Hawaii trip, and that was a success, obviously, because we're here now. So I just wanted to take this opportunity to thank you guys so much. It really did make the experience possible. It was pretty amazing. So I got involved with this project, namely through Astronomy Club. We do like a weekly meeting at lunch at our school, and Mr. Holt found that that was probably the most likely place to find candidates for our whole thing here, and so I hopped in and have been going ever since then, in 2019.
Hi, I'm Sophie and I'm a senior. I got involved through an email that was sent out to students who were going to be taking an astronomy class, and I thought the research sounded super cool, so I replied and I started coming to the meetings, and that's how I got involved.
Hello, my name is Kyle. I'm currently a sophomore at Memorial, and how I got involved is that, similar to Sophie, I just got an email for those people who were interested in taking an astronomy class the following year, and ever since then I just went to the after-school meetings, and here I am right now.
Hello, I'm Tessa. I'm a senior, and I got involved when a friend mentioned it to me. And I heard NASA, I heard research, and I was like, I'm in. We also have a fifth member of our team, Andres, who couldn't be here tonight.
Yeah, thanks for remembering to mention
yeah.
that. I'll put the slide back up and I'll show you which one is Andres. Andres has, for his privacy, I'm not going to give you the details, but he has good things happening in his household that are causing chaos. I think that's fair to say. All right, I'm not going to share my desktop. Keynote. So before you continue, Tessa, I'll point out which one is Andres. So that's Andres. So again, Isaac, Kyle, Andres.
Yes, curse these Zoom meetings with their bad internet.
All right, we're going to tell you a little bit about the astronomy research we did in 2019. So here's a picture of our whole team gathered in Hawaii, where we presented the results of our research at the American Astronomical Society conference in January.
So before that even happens, NITARP offers a week-long intensive training on-site at CalTech in Pasadena. So Mr. Holt and I were the only members of our Madison team who were actually able to attend, but it was a very informative and amazing experience. So the week included training on how to use the software we'd be relying on for our data analysis, and it vastly increased our background knowledge in astronomy. This was about 8 hours a day for a week of intensive training, and we came out with brains overloaded. We also got a chance to tour JPL, including a few of our favorite spots. This was the Mars Yard, where they test rovers for like how they'll actually drive on the surface. This is a model of the InSight lander, which they were using to hopefully scale in as real time as they could make it with how the actual InSight lander is looking on Mars to try and test for what they should do next. And this is the sort of construction, this is the assembly facility. So right there pictured, we got to see Perseverance, the Mars 2020 rover, being built on site at JPL, which was amazing.
Oh, and I want to mention that you can actually see the temperature probe that they were running tests on that they've been having so much trouble with.
We also got to see the star shade, which some of you might know is scheduled to go up with the James Gunn Space Telescope whenever that's scheduled to go up at this point. Who knows? But the star shade's purpose was to send it out way in front of the telescope, and then it's meant to block out stars in hopes that we can find exoplanets by reducing the light around them.
And it's not part of the normal JPL tour.
Right. It's not normally part of the tour, but my dad is actually a scientist working on a polymer that they're supposed to use to clean the star shade when it goes up. So we got to see a little extra.
So to explain our research, we're first going to review a little bit about stars. So they form out of a cloud of gas and dust. Areas in the nebula that are a little more dense collapse due to gravity and form stars. Young stars are often still surrounded by the gas and dust in the nebula. Most stars have leftover stuff orbiting around them, which clump together to form planets, moons, asteroids, and comets. These middle-aged stars shine for millions or billions of years. When they get old, stars puff up like cooked marshmallows to become red giants or red supergiants. In this stage, they often burp off clouds of plasma, which cool and condense to form dust particles like we think Betelgeuse did over the past 6 months. So the image there is a visible light image of Betelgeuse in the center and a scaled infrared photo of the ejected dust surrounding the star.
Our goal was to search for stars which are at interesting stages of development. So young stars, called young stellar objects or YSOs, sometimes still have dust around them before the star gets hot enough to blow or photoevaporate the material. Old stars, known as evolved stars, like Betelgeuse, often puff off clouds of dust. And some stars that are young or middle-aged can have disks of debris around them. We learn about these stars by the light they emit at all wavelengths on the electromagnetic spectrum. So the light that has slightly longer wavelengths than visible light, which we call infrared, are particularly useful in helping us to learn about these stages of development.
That's you, Kyle. Do we lose Kyle?
Might be muted.
John, can you see him in the list?
I don't see him in my list.
Yeah, he wasn't going to share his camera because of bandwidth issues, and yeah, I don't see him in the list. All right, now speaking as Kyle, Geoff Holt. So we can detect these stages by the dust that they have around them. The Spitzer Space Telescope was an infrared observatory uniquely suited for detecting light at these longer wavelengths. Spitzer's mission ended in January, but the archive data is still available and valuable for continued research. Now, all objects, and just so you know, in our planning for this, we knew that there would be a wide range of knowledge bases here. And so I know many of you have the knowledge base of a professional astronomer, but just to make sure that we weren't leaving anybody behind if you're just getting started in astronomy, we wanted to give some of the basics too. So all objects that have temperatures above absolute zero radiate energy. And the wavelength and intensity is determined by the temperature of the object. So by plotting intensity, like on the vertical axis here, and wavelength on a graph like this, which is called a spectral energy distribution, or an SED, these curves have a predictable shape. So we're talking about this shape here. For example, the 3,000 degree object peaks at a much longer wavelength than, let's say, like the 6,000 degree object. And the 6,000 degree object also has a higher intensity. And the shape of the tail here can actually tell us what temperature these objects are. As long as they are stars, stars represent pretty close to being black bodies.
All right, so notice the shape of the SED in the top panel for a star with no dust around it. Since typical stars resemble black bodies, the SED looks like a black body curve. Then, in the middle panel with the dust disk is absorbing the high-intensity short wavelength light from the star and re-radiating it at longer wavelengths. It changes the slope and shape of the tail of the SED on the right side. In the bottom panel, you can see what happens when there's a gap between the star and the dust. So stars that have dust around them emit more infrared light than other stars do, and we say they have an excess of infrared light. So our goal for this research was to create a catalog of interesting sources with an excess of infrared. This catalog will be used by astronomers for further study. The Spitzer Space Telescope data is publicly available online in the Spitzer Enhanced Imaging Products catalog. Anyone can access this data and use it for research. This catalog includes calibrated photometric data for 42 million sources at 5 different wavelengths. We focused on the 2 shorter wavelength IRAC channels, 3.6 and 4.5 microns, because of the higher resolution. And then we also used the MIPS 24 micron channel.
The main tool we use for data analysis is an application called TopCat. It's a graphical viewer and editor for data in table format. If you Google this app, you will want to include the terms TopCat and data analysis because there are many TopCats out there. We used it to visualize the data in graphs, and it allowed us to cross-match the sources in other data sets, including remote archives like the Gaia database. The window in the upper left is the main window. The lower left panel is a view of part of the data table, and the panel on the right is the interface for creating plots.
So we searched the Spitzer Space Telescope data archive for sources that are fainter and would not have been detected in previous studies. So in this initial query, we found over 500,000 stars. This plot shows those sources by their galactic coordinates. So the graphic you see in the background is a visible light mosaic of the entire sky created by Axel Mellinger. Horizontally across the center of the image, you see the plane of our Milky Way galaxy. The 2 large clumps you see below the plane are the Large and Small Magellanic Clouds. And any other clumps you see are usually caused by selection bias because of surveys that were focused on a specific region of the sky. So for the next step of our process, we only wanted the sources that we had good, accurate distance measurements for. So we only kept sources that had a good signal-to-noise ratio from Europe's Gaia satellite. So that left us with a little over 2,000 stars.
Do we have Kyle back yet?
I don't think so, Jeff.
Okay. Well, then we eliminated any stars that were already known to have an excess of infrared. To do this, we cross-matched our data with the SIMBAD database. And to concentrate on the most interesting ones, we eliminated stars that were in the central plane of our galaxy. And so we only included sources that were at least 1 kiloparsec above or below the galactic plane. And that left us with 238 sources. Then we went through a process where we visually vetted each of our sources. We were concerned about any source that its data could be contaminated by any nearby sources or extended objects. And so using IPAC's Ursa viewer, which you're seeing here, we were able to look at each of the sources that we had pulled from the database. Now notice that the IRAC channels 1 and 2 have higher resolutions, and that's what Tessa was talking about, why we are using 1 and 2 and did not use 3 and 4. But we needed the longer 24 micron channel in the MIPS instrument just to make sure that we had data points farther down that, that tail of the black body curve. Now note the one on the right, we rejected because, you know, both in IRAC-1 and in MIPS-1, we could see that there's something sticking out over here. So we had to do that for each of our sources. So by the time we did the visual vetting process, these were our final 103 sources plotted on galactic coordinates.
All right. In order to detect sources that have an excess of infrared, we plotted our vetted sources on what is called a color-color diagram. The horizontal axis is the ratio of the intensities of these sources at two different wavelengths, 3.6 and 4.5 microns. The vertical axis compares 4.5 and 24 microns. Any sources on the right side of the plot have an excess of infrared at 4.5 microns, while sources in the top half of the plot have an excess of infrared at 24 microns. So sources in the upper right would have an excess at both wavelengths. In the end, we had 99 newly discovered sources that have an excess of infrared light, which is probably from dust around them. They are shown in blue in this diagram.
So here are our final sources in blue and green plotted on a color magnitude plot, which you may also know as an HR diagram. The red dots are stars from a larger data set to provide a reference for analyzing our sources. A color magnitude plot shows us what type of star they are or what stage they are in. Stars at the top of the graph emit large amounts of energy. Stars on the left side of the graph are the hottest. Stars in the upper right are red giants. Stars in the lower right are red dwarfs. Stars along the slanted line are called main sequence stars and are thought to be middle-aged. The blue sources are our newly discovered sources with an excess of infrared. And we were surprised to see that many of the stars we discovered were middle-aged stars. Stars on the main sequence are the least likely ones to have dust around them. We are wondering if these stars are in a transition phase between YSO and main sequence, or if a collision of protoplanet bodies created a dust disk. We also speculated that they might have formed out of the plane, as was suggested in a paper recently published in the monthly notices of the Royal Astronomical Society. We're hoping to follow up on these possibilities if we can get some telescope time and guidance from our mentor astronomer.
So we were really excited to be able to present the results of our research at the American Astronomical Society conference in Hawaii this past January. So it was an amazing feeling to see our names as co-authors on this research paper you can see here. So here's our poster. This was our final poster which we presented in Hawaii. Our Madison team actually took the lead on its creation. We all sort of talked about it afterwards and decided it sort of felt like a really high-risk science fair project. But it was a very rewarding and creative process. And we were especially happy with our decision to plot the sources by their galactic coordinates with the all-sky mosaic in the background. So here's our team in front of our poster in Hawaii. The experience was definitely different than anything we've ever done. Explaining our research to actual professionals in the field felt more lifelike and influential than anything I've experienced and the other students have experienced in school. The other researchers asked amazing questions and they offered suggestions for continuing our research. So at the conference, when we weren't presenting our poster, we really enjoyed going to keynote presentations and press conferences. We got to see other people's posters, and there was a main floor as well with exhibits from all kinds of organizations. We would love to keep investigating and learning about our stars with infrared excess if we get the opportunity.
Now we want to share a little bit more about our experience at the conference and our time in Hawaii.
All right, so we've told you about our research, and now here's kind of like the fun stuff we got to do in Hawaii while we were there. Here's a picture of the convention center, and as you can see, it kind of just goes straight outside. There's not always like walls or windows or doors, So it was really nice because when it was like nice outside, it was nice inside. And then here's a plaza that is looking back at the door that we just showed you, or like the open entrance.
This was one of my favorite keynotes. I don't know if you guys have heard much about the Polynesian navigation by the stars. If you've seen the movie Moana, you at least know a little bit about it. I'm a big fan. So you can see the voyaging canoes here. This speaker is one of the captains and navigators of one of the voyaging canoes. And he was talking about his experience on the voyaging canoes. And he told the story of how hard it was to eventually convince his daughter to be a crew member. And she eventually went on to become the first navigator and first captain of one of these voyaging canoes. I thought that was pretty cool.
So this was a on-floor presentation that was sort of in the main stage of the open convention center that captain was doing. I think I might have been the only one in our group to actually get to sit through the whole thing. It was pretty incredible. He explained how they didn't have compasses or any sort of navigation tools. Well, he does, but in their form of navigation, they don't use them at all. They only use sort of star houses. You can see in the background that Haka and Hema and Naleo and things like that. They only use these star houses in the form of constellations to navigate all around the open ocean.
So just like being in Hawaii and like coming down from the plane, you could see so many beautiful things. And in this picture, there is Mauna Kea and Mauna Loa. And it was really fun to be able to spend time in Hawaii, and like our resort was right on a beach. So this is us hanging out one of the nights at the beach. And we got to go stargazing as well, which was super cool. And we got to see a lot of, a few southern constellations that you can't see from Madison, like the Southern Cross.
So before our conference, we arrived in Hawaii one day early to do as much sightseeing as we possibly could within the one day before we were in the convention center for the rest of the time. And so for part of that, we decided to hike Diamond Head. We did get to see a mongoose, actually. That sign is not hyperbole. It was very exciting. So this is the view from Diamond Head. It used to be a volcano about 500,000 years ago, and then that sort of went away, and it turned into this volcanic cone, which happens to be very beautiful. So here's a few more pictures cycle through.
Oh, by the way, these are like old World War II bunkers up on the top of the cone. Super windy up there.
So here's a picture of our resort. As everybody's already said, it was beautiful and we were right on the beach. So yeah, we just got to enjoy, kind of being in Hawaii on our very limited off time. We got the opportunity to go snorkeling right off this beach here, and we actually saw a sea turtle, which was probably one of the highlights of the trip. And then, yeah, in the background there, you can see the volcanic crater. And then here we are kind of on our walk to the conference center. It was a little bit over a mile away, and we just got to walk there every day and kind of enjoy the weather. And it was a ton of fun getting to go outside and just be there.
Now, I was hoping that Andres would be here to tell you this part of the story. So that's Andres. He has family in Hawaii. His uncle is stationed at Pearl Harbor. And so he was able to make arrangements for his family to come and pick us up. So this is us hanging out waiting for his family members to come and pick us up. Now, we couldn't take photographs on the base, but we got like a behind the scenes tour of the base. This is about the only place we could use cameras. So this is the Air Force part of the base.
So our days were pretty busy with the conference, but during the evenings we had some time to relax. So we got some ice cream and hung out with the rest of our team, which was really fun.
So on our last day there, once the conference was over, we got to go to the Bishop Museum, which was a great way to find some more about Hawaiian culture and things about there. So it was half outdoor, half indoor, and we also got to see some apparently terrifying wildlife that is contained within the Hawaiian Oceans. For any Ridley Scott fans out there, apparently facehuggers exist and they're in the ocean, and that scared me to my core. So there you go.
Hey, Mr. Holt, says Kyle's on here. He's the call-in number. So he's asking if you can unmute him.
John, can you get that?
Okay, can you hear me now?
Yes, we can.
Yep.
Yes.
Yay.
Okay,
Kyle.
finally. Well,
Sorry.
it's too late now. Oh well.
So we're just finishing up, but Kyle, how about any other things that you want to share about your experience on the team? Kyle was not able to go with us to Hawaii, but he was part of our research team.
Yeah. I mean, I just find it pretty unique because, first of all, you have astronomy research. Not all high schoolers are able to have this kind of experience, working with fellow astronomers, and just having that kind of experience with astronomy and actually doing this kind of research project. So I find it pretty unique and also a fun experience to do for the school year. And I think that's pretty much it for me.
Cool, thanks. Well, so folks, that's our research and that's our experience in Hawaii. You might say, well, I would say it was a stellar experience. And we learned more than we could have ever imagined. We thank you all so much for your interest and for your financial contributions to help make this amazing trip and the research possible. So, John, do we have any questions pop up already in the chat?
We do have a couple of questions. So Kyle, I'm going to leave you unmuted so you'll be able to respond also to any of the questions if you want to. I'm going to go first. And my question is not about your research, but I think Tessa and Sophie, you indicated that you guys were the two seniors in the group, I believe. I don't remember if anybody else was a senior. I'm wondering if your chance to do this research over the past year plus, has it reshaped your plans for college? Has it reshaped what you plan to study or where you applied or any other aspect of you heading off next year?
It definitely affected it for me. Going into this, I didn't really know what I wanted to study. But coming out of this, I definitely, I'm super fascinated by astrophysics and astronomy. So I think I'm going to major in physics.
Yeah, I don't know that it affected so much where I was applying or what I think I'm going to study. I'm still undecided, but I've always been kind of a science gal. And so it was really, really cool to have this experience doing real research with real astronomers. And I just think I'm going to be so much better prepared for college classes and internships and that kind of thing.
Another side question, did you guys meet any celebrity astronomers in Hawaii?
Oh, yeah. So the team didn't, but as we were gathering, our typical mode of operation for keynotes was that one of us teachers would go in early, and one or two of us would go in early and try to get a whole row, because we took up a whole row in the keynote rooms. And then we would stand there looking toward the door so that the rest of the team would recognize us and know where we were. And so I'm standing in front of an astronomer who probably feels like, oh, this guy probably wants to talk to me. And so he looks up and says, hello. And I look down, it was Alan Stern, principal investigator of New Horizons. And so I just like totally like fanboyed out and said, no, I just want to thank you for how inspiring you are for our students. Your energy is contagious, and for the incredible work you did leading such a great research team. And he said, oh, wait, the best is yet to come. He said, you know, we're just publishing now some foundational research on like how the solar system formed, how early bodies first formed. And so if you've been following the New Horizons research releases, that was what he was talking about. Came out at the conference or just soon after.
I completely forgot you got to do that. You've resurfaced my jealousy.
So for Kyle and Isaac, any responses to the question about your post-high school plans based upon your involvement now in astrophysical research?
For me, absolutely, actually. So I've known that I wanted to deal in some form with space for, I don't know, probably since like first grade. When I wanted to be like an astronaut who read story time to children on the moon, you know, general first grader things. But but going out of this, I think for a very long time I've said I wanted to be an aerospace engineer, and I think this actually really changed that for me. I realized that I don't know if I really want to do super physical work. I think that actual research might be something that I enjoy a lot more than engineering. So yeah, it's absolutely shaped something for me.
Cool.
And Isaac is continuing on as part of the 2020 research team. And I think, Sophie, even though you're graduating, you've been taking along as well, right?
Yeah.
Do you guys want to say anything about like the subject of your 2020 research? We didn't prepare this.
We can mention it. We're focusing on young stellar objects for the most part, specifically in the Spider Nebula, which is pretty cool. And I haven't thought about it for a while. Sophie, do you remember the IC 417? Is it?
Yeah, IC 417.
Yeah. So like formation and finding young stellar objects in the Spider Nebula, which has been really interesting. I think, for me at least, having a full year's worth of experience behind me coming into this year's is so formational. Like I remember sitting at the beginning of these meetings and being like, all right, let me write down nothing because I don't even know what to write down. And now
Yeah.
I have an idea of what I'm actually listening for.
Yeah, I definitely had like a notebook that was just like astronomy terms with like question marks after them. So.
And
Yeah.
after we would start going through and talking about each one. Go ahead, Sophie.
I was just going to say, yeah, I definitely had a lot of questions when we first started this, but doing this the second year, I actually understand a lot of it, which is really cool.
Okay, another question coming from the group this time. Kevin and Carol, you guys modified your question after the fact, but do you want to go ahead and ask the first part?
Sure. I was just wondering, I can't remember if it was Tessa or Sophie was talking about the desire to do more research on some of the excess IR stars. That would that additional research be involved in looking for formation of exoplanets?
Anybody want to take that on?
I could give it a
I
shot
mean,
if no one else. Oh, go ahead, Kyle. I didn't mean to interrupt.
oh, you can go.
Okay. Short answer, probably not. It'd be really cool to look for exoplanets, but for the most part, that's a little bit beyond our wheelhouse, I think. We'd have to talk to our astronomer, Varajan, about it. But if we were gonna continue research, it would probably be actually on why they have infrared excess. I think we hinted about it a little bit. I don't know if we went into enough detail, though, is that we found all of these stars were on the main sequence. They were pretty ordinary stars, which is really uncommon for stars with infrared excess. At that point in their life, they usually don't have dust and stuff around them that re-radiates that stuff out at infrared. So if we were going to keep going with research, it'd be finding out why we're even getting these results.
Okay.
That would involve getting telescope time on an instrument that has a spectroscope.
Yeah, I just wanted to say how impressed I am with the presentation and the level of detail that you guys are going into. It's just very impressive.
Pretty smart kids.
Thank you.
Shouldn't say kids.
So another, more of a comment from Dan Hislop, but Dan, did you want to go ahead and, did you want to throw that in for the group?
Yeah, sure. I just, you had mentioned the bit about seeing the speaker talk about voyaging in the Pacific, the Polynesians. And I was in Hawaii last year and someone had recommended this amazing book to me. The author is actually at the Bishop Museum. The book is called Shark Going Inland is My Chief. And the book is about the Polynesian culture, how they settled Hawaii, and how over the hundreds of years after that, their culture diverged and became much more complicated than the Polynesian culture. It's just a really amazing book if you're interested in that.
Sounds pretty interesting. I am not familiar with that, and I see the question from Steve about the last navigator. I'm not familiar with that either. Is that about Mao? Like the last one that they were able to find that still knew the old ways of navigating? You're muted, Steve.
He's in the Mariana Islands, and Steve Thomas got a hold of him and did some navigating with him and wrote a book on the experience.
Yeah, we used to have a planetarium show called Explorers of Polynesia, and it told the story of the Hokulea. And so that's how I got to first know the story of Mao and Nanoa, who was the first navigator in, to learn kind of the science behind the traditional ways of navigation and kind of reinterpret them. He was the one then with Mao to teach the rest of the navigators. And it's a great story. And so I am interested in learning more about it.
Yeah.
We did purchase the license to be able to present, I don't remember the name of the planetarium show that we saw at the Bishop Museum, but it's one that they produced there about the Polynesian navigation. We planetarium people totally missed the boat and missed the opportunity to capitalize on Moana when the movie first came out. It wasn't enough of a hit that people were really talking about it at the time. But I get a lot of mileage out of it now.
Moana was a pretty big hit. I don't know what
Yeah.
you're talking about. That movie was
I definitely went and saw it in theaters.
Did you?
Just a comment, if anybody gets a chance to go back to Hawaii and go to the Big Island, Carol and I had the experience of actually going out to Mauna Kea Observatory when we were there. It was actually snowing at the top and there was a snowfield, and all the residents were filling up their pickup trucks with snow and taking them back to the beach.
Oh my God, I remember you were telling me that story when I presented at MAS, and I totally was sad that I didn't get to do that. I wanted to do warm snowball fights.
Yeah, the trip up there was pretty much an adventure because the roads are pretty much a corduroy type pattern, and we went up on a 4-wheel drive Jeep And it was an interesting experience just getting up there and trying to hit the right harmonics on that road.
But beautiful at the top.
Yeah.
I don't see any more questions popping up, so I just want to say to the group from Memorial, on behalf of MAS, we were all disappointed that we didn't get a chance to do this meeting in person with you, because we really wanted to, be able to interact with you personally. But we're very grateful that you guys agreed to the Zoom. And I know that Geoff got you guys together to rehearse this so that your presentation was well thought out. So thank you all for the time that you spent doing that and getting ready for this. We always, when we see students, especially kids your age, presenting to us like this, let you know that there's an open invitation. When you come home from college or graduate school, we will find you and we will get you to speak at an MAS meeting coming up, maybe in a couple of years, maybe a couple of more years, whatever it is, but we'll be looking forward to that.
Just to kind of tie into that, I don't know if we really told this part of the story enough to make it obvious, but the students and I, we were collaborators, and this was not a teacher-student relationship, and so it was the same in the work putting together this presentation. We did it collaboratively. The research and learning all the background information, I might have had a little bit of a head start, but for the most part, we were learning a lot of this together.
Yeah, it's great. It's great to learn how to collaborate in a team and peel back all the layers of the onion that you're trying to uncover and learn about. It's a great experience. I just got to say, great work. And I think one of the great things about being in part of any organization, whether it be the American Astronomical Society or the Madison Astronomical Society, is to be able to network with people with similar interests and have a positive influence on your community. And I'm sure I'd like to congratulate all of these students for having such a wonderful impact on their schools and their communities as well with this great project. Bravo. Thank you so much.
You too. Jürgen, unmute.
Oh, thank you. I found this absolutely fascinating, and I find it also very interesting. The news is always filled with big science. I'm very interested in the small science and the types of things that can be done at this level, because there are, with the collaborative projects, AAVSO and things like that, there's room for people who are doing much smaller science that's still very interesting. And if we could, as long, Geoff, as you're doing this sort of thing out at Memorial, I'd like to see kind of annual presentations if they can be arranged. I think these are fascinating.
Well, I know that the 2020 team will be looking for ways to share their experience. And if we can continue our work on our 99 sources, we will definitely share that experience. And if anybody wants to learn more about how to dive in and do queries into the SEIP database for Spitzer data, I do have the procedures written up, and so I can give you kind of a first level of assistance just by sending you a PDF, and then provide remedial assistance along the way if you get stuck.
We have another question that just popped up, Geoff. A question from C Cow.
C Coles.
Charles.
Go ahead, Charles.
Yeah. Hey. Yeah, I just accepted the default that it assigned to me on Zoom. I just have a question for anybody out there listening. I never really understood something in radio astronomy that I think relates to what you guys were observing here with infrared radiation, and that is that you can detect clouds of hydrogen using a radio telescope looking at the 21 centimeter band.
Mm-hmm.
Why is it that hydrogen just radiates at 21 centimeters. What the heck is going on there?
I've actually, we have access to the 30-meter radio telescope in Green Bank. And so I've taken a couple of groups of students through the process of using those H2 clouds and measuring their velocities using the peak at 1420 megahertz, I think, that 21 centimeter line. And they told me at the time, at one point I kind of half understood. It has something to do with a flip that happens possibly in the polarity or something. Don't take what I say, but if you just look up, why that 21 centimeter, 1420, 1410 peak happens, there's a pretty good, explanation out there.
Okay.
I've had to look it up before. If you have trouble finding it, let me know, and I think I can find it again.
It doesn't have anything to do with light, right? It's not an electron falling down from an excited level down to one lower.
I think it is, but I think it's more complicated than that because it's just there's some like twist in there. For some reason, my mind is remembering the twist.
Okay, thanks.
Last call. All right, Lawrence, I'll turn it back over to you for any final comments.
Well, thanks everyone. Yeah, this was a really great talk, and I'd really like to thank everyone who put in an awful lot of effort over this whole year into this presentation. And yeah, it just, I know, yeah, a little bit speechless, but yeah, really encouraging what we're doing in our schools these days. And it really sets a great example that, you can go out there and find a little niche to look into, and there's resources in the community to be able to do it if you want. I'm kind of quick looking at our calendar. Our next meeting is scheduled for looks like Friday, June 12th. So we'll keep everyone on the loop as what's going on, whether if there's a remote chance we can meet in person at Space Place, or if we're going to continue meeting here on Zoom. And we'll also be looking for results of the Madison Astronomical Society Board of Directors election on, I'm looking at the wrong part of my calendar again, on Sunday, May 31st is when we'll announce the results. And again, any ballots we receive through email or by US mail by Saturday, May 30th will be counted. Does anybody have any questions or insights or ideas before we sign off for the night?
While you're thinking, let me just take one more opportunity to thank everybody in the organization for helping to support this next generation.
You're welcome. Pleasure.
Most welcome. Worth every penny. Well,
Geoff, once again, thank you. Thanks to the Memorial kids. And Lawrence, I did have a thought. Do we want to say anything about hats or mugs?
We ought to figure something out.
We have a tradition of giving a small token of our appreciation to presenters. Either a coffee mug or a baseball cap with the MAS logo on it. We can make arrangements. I mean, I know that I can get them to Geoff fairly easily, and I'm assuming that Geoff would maybe have the wherewithal to somehow sterilize, disinfect, and maybe pass them on to the students. So let Mr. Holt know if you'd like a coffee mug or a baseball cap, and we will find a way to make that happen.
Curbside drop-off. Supermodel Win is showing the baseball cap.
It's not the exact same thing, but there's the example of a mug right there. If you like to get mugged or capped, it's up to you.
Yeah, so kids, let us know. Mr. Holt, no.
Well, if I were a college student, I'd definitely go for a coffee mug.
All right, everybody, thank you. I'm going to stop the recording